The one thing I probably didn't emphasize enough with this notes is memorize everything. You need to know the terminology and you need to know the rules. It saves a lot of time. This next one's a very common sense theorem. It says if the inscribed angles of a circle intercept the same arc, then the angles are congruent. And I tried to white these out once, but can you tell it didn't really make a difference? So then the angles are congruent. What does that mean? Well, if I have multiple inscribed angles that share the same arc, like this one right here, notice all three of these vertices, C, D, and E, I can make inscribed angles that intercept that. Well, if I know the measure of one, let's just say this was 50 degrees, that angle would have to be 25. If that's 50 degrees, that one's 25. If this is 50 degrees, that one's 25. So it's very easy to say, oh yeah, they're all going to be the same. But look at this one over here. It says, what about angle CAE and angle CBE? Well, this one and this one. Well, they intercept this arc CE on their own. So it just matters you can have different inscribed angles with different arcs. So it's not too big of a deal. So let's go ahead and apply this to our advantage. Now don't forget to use everything you already know about arcs, like sum of the parts equal the whole, what's an adjacent arc, know that the arcs of a circle add up to 360. I don't want to have to change that if I can help it. So looking at this next one, I want to find the measure of angle ABD, this one from here to here. And I want to find the measure of angle ACD. Well, if I look at my pieces of paper here, I don't know the degree measure of the arc. So I have to come up with a different way of doing this. So this is when I asked my question that's on my wall, how am I going to get there? Well, you need an arc. So what do I know about this circle? All the arcs add up to 360 degrees. I'm missing only one. So first, I have to find the measure of arc AD. Well, it's going to be 360 minus all of those added together. So what do I get here? I got 140 plus 70 plus 30, so that's 240. That's going to leave me, what, 120 degrees. Boy, I can't do my math very well. So this is 120. Now, that angle is half the intercepted arc. So the measure of angle ABD is 1/2 of 120 degrees, which equals 60 degrees. Now I have to do the same thing for ACD, or do I? Well, look what happens. ACD intercepts the exact same arc. Well, since they have the same arc, they're exactly the same in size, so I can go ahead and mark that they're congruent. So I know the measure of angle ACD equals 60. So it's not too bad. Let's try the next one. Find the measure of angle EDF. So I'm looking for this one right here. Well, I have these two angles marked. I have no arcs, so the arcs aren't going to help me, but do they? Well, do we have an intercepted arc that both of these two angles share? Well, if they have the same intercepted arc and they're both inscribed angles, they're both going to have the same measure. So we know that they're congruent. So I can go 2x plus 3 is equal to 75 minus 2x. Add 2x to both sides, so I get 4x. I'm going to subtract 3 from both sides, and I'm going to get 72. Make sure I'm laughing at my notes, guys, because you know how I make arithmetic errors all the time, and I even did it when I was doing my notes originally. 72, divide by 4, you should get probably 18. All right, so x is 18. So I'm done with the problem, right? No. I'm going to ask myself a question again. Where do I want to go? I want to find an angle. So I need to plug it in, plug it in. All right, so I get the measure of angle EDF is equal to, when I plug this in, 2 times 18 plus 3. So that's going to be 36 plus 3. Be 39 degrees. All right, let's do one more. And you guys are going to call this the common sense biconditional. Remember, biconditional means it happens both ways. There's no way around it. Here's what it's saying. An inscribed angle subtends a semicircle if and only if the angle is a right angle. Basically, what they're saying here, if I have an inscribed angle and it's a right angle, I will always intercept a semicircle because it's 180 degrees. And since an inscribed angle is half of the arc's measure, we always know it's 90 degrees. So I can even form these other triangles as long as I have that intercepted arc I know they're all 90 degrees. So you can have this one here and this one here. So I'm actually pretty happy with that. So the thing is, just know the rule. Look for, and here's another thing, look for diameters whose endpoints of the diameter are also endpoints of chords that make inscribed angles. So when I look at this next one, it says find the measure of angle A. Well, looking at that, I have a diameter. So the instant I see that this is a semicircle, I realize that this inscribed angle right here has to be a right angle because I have the semicircle. So I know that like instantly. So when I'm looking for the measure of angle A, I just have to set it equal to 90. So I get 5A plus 20 is equal to 90. 5A is going to equal to 70. Go ahead and divide by 5. Goes in there evenly, which I like. So that's going to be what? 14, I do believe. So hopefully that helps us get that one.